All right, in this video, we are going to look at how we factor polynomials when we have four terms. And then at the end, we're just going to do a little bit of review of the strategies we already have. So this video is going to cover factor by grouping. And so before we start factoring by grouping, I think it's important that we look at the big idea behind it. And to help us do that, we are going to look at how I would factor out the GCF in each of these expressions below. So if you look, there is a theme. All right, so here a 5w and a 3xw, we can take the w out. All right, now if I factor out the w, then I'm left with the 5 plus the 3x. And so we've done this, right? We have spent time factoring out GCFs. If I look at the next one, I see that they have a y squared in common. So even if I have the y squared out, I'm still going to be left with what's there in blue, which is the 5 plus 3x. Now, when I jump down to these at the bottom, what changes here is the important part of factor by grouping is even if what they share is an expression or a word, you can still factor it out. So if I look at this problem here, notice these have the word blob in common. So I could take out that word blob and be left with the 5 plus 3x again, right? If I take the blob away from each of these, then what's left over? Here, I'm going to go ahead and look. I have a 5 times a w plus 2 plus a 3x times w plus 2. Well, these have the w plus 2 in common. All right. And so there, I have the 5 plus 3x left over again. So what's really important is up to this point, we've only done problems where the GCF is kind of this single term we get to take out. Today, we're going to transition to where we're going to notice that they have a binomial in common that we are allowed to factor out. All right, so let's look at our first example of factoring by grouping. So the first thing I want you to notice is we have 1, 2, 3, 4 terms here. All right, now with my 4 terms, the very first thing we're going to do is we are going to divide this expression down the middle. All right. So when I say that, I just want you guys to kind of draw a squiggle line down the middle. But what's really important is this plus sign needs to stay with the 2x. So whatever the sign is has to stay with this term. So don't draw your line over the operation. Actually make sure that stays on the right-hand side. So what I have here is I basically have 2 different GCF problems. So when I look at this first problem here, I would say x cubed plus 7x squared. What do these have in common? Well, these have an x squared in common. So I'm going to take out the x squared. And when I do that, remember, that's just like dividing out an x squared. So if I divide out an x squared and divide out an x squared, then I'm left with an x plus 7 here. All right. When I do the exact same thing on the other side, a 2x plus a 14, well, that has a plus, whatever this sign is, plus 2, and then I have an x plus 7. So let's think back to what we just finished doing with our blob, right? Notice here, we have a blob and a matching blob. So I'm actually allowed to take out x plus 7, and then what's left over are those terms that are on the outside. So if I take the x plus 7 away from an x squared, I'm left with x squared. If I take an x plus 7 away from a 2 times x plus 7, I'm just left with that plus 2. And this is my final answer. All right. So let's go ahead and try another one. All right, here. Step 1, we draw the line down the middle, right? Now again, that minus needs to stay with the 2. Do not draw the line over the sign because that sign needs to stay with the 2x. All right, so I look here, take out a GCF. In this case, my GCF is a 3x squared. And when I take out a 3x squared, I'm left with x plus 5. Now, same deal over here. What can I divide out from a negative 2x minus 10? Well, I have to take the minus out. Whatever that sign is going to stay there. And then I'm dividing out a 2. Now, be careful. I'm taking a negative 2x minus 10, and I'm dividing out a negative 2. So just be really careful that you recognize that this needs to say x, and that minus and minus actually is going to turn to a plus 5. And now what you guys should see is that common term again. On the first slide, we called it a blob, right? But now I see I have an x plus 5, and then the leftover terms, which are my 3x squared and my minus 2. And this is my final answer for doing a problem factor by grouping. All right. So there's just one other little curveball I want to just point out to make sure we don't get confused. So draw the line down the middle. GCF, so in this case, it's a 3x. All right. And so then when I take out the GCF, I would get an x minus 7. And then when I look over here, so again, let's not forget, whatever this sign is just drops down. That has to be the sign here. But an x and a 7, those actually don't have anything in common. So what's essential here is you have to put something here. And so when two terms don't have any common factors, it actually means they have a common factor of 1. So you do have to write a 1 there as a space holder because our final answer has to be a binomial times a binomial. So the x minus 7 is the common term. And then I'm left over with the 3x plus a 1. So if you don't put this kind of filler here, the placeholder of a 1, then you're not going to get your binomial for your second term. So just remember to put 1s in. All right, so that's the new stuff. And this we use, again, when we have 1, 2, 3, 4 terms. I just want to take a quick chunk of time to remind you, we've already done binomials. So remember, binomial means we have 2 terms, okay? So 2 terms, the first thing I want you guys to look at is it a difference of perfect squares? So x minus 3, x plus 3, all right? The second here, right, 25x squared minus 81, I see perfect squares again. So this is a 5x minus 9 and a 5x plus 9. All right, so when we see 2 terms in a problem, our brain needs to think or ask, is it a difference of perfect squares? All right, and then the very last one we've already kind of spent some time on is trinomials. So trinomial, like a tricycle, means we have 3 terms. And this is where we're going to use our Xbox strategy, right? We're going to ask ourselves factors of a 20 that add up to a negative 9. We're going to remember that we can start filling in this box with the x squared from here and the positive 20 from here. And when we think about all of our factors of a 20, right, we need a set that are going to get us to a 9, a negative 9 actually. So here I would use negative 4 and negative 5. And see, this is why GCFs are really important because, see, I'm using that same concept of GCFs when I do this part. So I would take an x out from here, a negative 5 out from this row, and then when I switch to my columns, an x from this column a -4 from this column, and my final answer here would be x minus 4, x minus 5. So those are our three strategies now for factoring. It's kind of nice because you actually can look at the number of terms to kind of guide your thinking. 1, 2, 3 terms, we should be using Xbox, right? 1, 2 terms, we should be checking for a difference of perfect squares. And when we have 1, 2, 3, 4 terms, we have to do this divide down the middle and do factor by grouping.